Ladies and gentlemen, thank you for coming today to this event. This event is called Decarbonization Beyond Electricity, and I'm very pleased to welcome three guests with me. On your right, we have Alice Cunha da Silva, who is a nuclear engineer and innovation project lead from Brazil. To her left is Edward Stones, who is business vice president, energy and climate for Dow. And finally, on your left is Kirsty Gogan, who is founder and managing director of TerraPraxis. So thank you, all three of you, for coming here today. And we're here to talk about decarbonization beyond electricity. And why does that matter? And the reason is that although decarbonizing electricity is very important, and electrification of sectors that don't use electricity but could do is an excellent way of achieving decarbonization, most energy isn't associated with electricity. And that can be a lot harder to decarbonize, but nuclear can be one of the technologies that's going to help achieve that, and that's what our three guests today are going to be discussing. So I'd like to turn the floor over to start with to Alice. Could you please introduce the topic to us and talk perhaps about the opportunities there are for using industrial heat and other forms of energy supply nuclear technologies?
Thank you very much. So I would like to start with a comparison that I heard last night in one panel that I thought it was a perfect example of what the complicated task that we have to achieve. And that energy transition is like operating in a beating heart, right? We need to decarbonize, we need to achieve the net zero while we are still dealing with a live economy, while we are still understanding the different needs of the different countries, like the ones in the continent that we are in here, that still need a lot of increasing demand in electricity in order to have the basic needs of millions of people that don't have access to energy yet and live in energy poverty. So it is not an easy task, and that's why we need to have a lot of efforts in parallel to each other and not wait to decarbonize electricity and then go to other sectors. So we need to have a lot of effort in parallel in many sectors, and we need a lot of innovation to that, because right now we need to leverage all the technologies that we have in our hands, but we need to continue pursuing innovative solutions for this global issue. One thing very interesting to the nuclear technology is that nuclear reactors not only produce electricity, but they have thermal power, right? So we can leverage this thermal power for different applications that includes hydrogen applications, that in hydrogen is very important for now and the future as the fuel for the future for many sectors. We can use for district heating, and that is already being done in many countries, but that can also be expanded. And we can use also advanced nuclear technology with energy storage, for example. There are research and development and innovation in new reactors that we already come with the design of joint energy storage, and that can help leverage the changes in demand of energy. So in a day that you are producing, the demand is high and you are leveraging full power of the reactor. In another day that you have more renewables operating, instead of load falling or decreasing the power of the reactor, you can leverage energy storage and that energy will be used in a peak of demand in another day. So this is being developed, and new nuclear technology can help with that as well. There is water desalination and many other applications that nuclear reactors and nuclear energy can help us to achieve decarbonization beyond the electric sector. And innovation is essential for that. Collaborate between different organizations, between different industries, so we can find synergies. I particularly work with open innovation, so finding startups and tech companies that are developing disruptive technology, and how can we incorporate that in order for us to be more efficient, in order for us to have a more innovative technology that can help us achieve what we are looking for. So for our sustainable development, we need to be continuous innovating, and nuclear technology is definitely a huge part of that for many sectors.
Thanks very much, Alice. Now, you were talking there about using the energy from a power plant for things other than generating electricity, but of course, for energy, some of that's mobile, some of that is used in liquid fuels, petroleum, and so on. So I wonder, Kirsty, that's the problem we have. It's not just decarbonising large plants, it's also looking at other sources of energy. And as the mic has reached you, perhaps, do you have a way in which nuclear can contribute to that?
Yeah, thank you, Jonathan. And to build on Alice's excellent comments, absolutely. We use 100 million barrels of oil per day right now. That's a lot of liquid fuels to decarbonize. And obviously we would like to, build out our electricity generation systems and then expand electrification. But some sectors are going to be really hard to electrify. And in particular, heavy transport, so marine, shipping and aviation, but also many industrial processes that really require high temperature heat. And this is an important application for, both of these are important applications for SMRs. So just to take the 100 million barrels of oil per day that we use, we've done a lot of work looking at the application of high temperature heat, and actually, conventional gigawatt scale like water reactors can be applied for hydrogen production as well. But the beauty of the dedicated hydrogen production with new small modular reactors is that it completely transforms the business model for nuclear technology. You're no longer constrained by the size of the electricity market or by the need for a long-term power purchase agreement. You don't need access necessarily to the grid because you're no longer producing electricity. You're making a commodity which can be stored, transported, and exported to global markets. And that's really important because it means that you can locate your site where it's convenient for you, and you can have a very large scale, like a refinery scale, production facility. Now, that large scale production facility, let's say a 20 gigawatt thermal production facility, for example, enables the pipeline of orders that is required for you to shift your capital investment into the manufacturing facility. One of the big challenges that the SMR developers face today is getting enough customers to order enough products for them to be able to invest in their manufacturing facility. And that's one of the barriers in terms of moving from a traditional project-based approach to a manufacturing-based product approach. So the hydrogen gigafactory that we've developed as an illustration of that. It's a very high productivity, very highly automated manufacturing facility integrated with the installation and production. They're all co-located, making around 2 million tons of hydrogen per year, which can be converted into synthetic fuels. And I would say that we see relatively niche applications for hydrogen as an end-use fuel. Certainly in refineries and in industrial processes, if you can co-locate hydrogen production with those facilities, then you have an off-taker right there that can use that emissions-free hydrogen in their upstream operations. That's fantastic. But actually hydrogen, as we know, is very difficult to store and transport and move around. So it's much more favorable to be able to convert that into synthetic fuel like ammonia, synthetic hydrocarbons. Now, for those alternative fuels, for synthetic hydrocarbons and ammonia to match the cost and performance of the fossil fuels that we use today, the key ingredient, hydrogen, needs to be about $1 a kilogram, and that's what you can achieve if you've got a kind of production at the scale that we're talking about here.
Okay, thanks. And I wonder before turning to Edward, you present the idea of the hydrogen gigafactory. How much would one of those gigafactories produce? If we're looking at trying to go for net zero, in the challenge of removing all use of genuine fuels, non-synthetic fuels, what could be achieved? What scale are we looking at?
Well, so just to give you an idea, 10 of these medium refinery-sized gigafactories which is the 20 gigawatt thermal facility as an example, 10 of those would entirely replace the UK's current oil and gas consumption, with, of course, a tiny environmental footprint and a lot of flexibility about where you locate them. Now, there's a lot of revenue streams from the gigafactory, not only, power and heat and hydrogen, all of which could be, supplied to consumers, within that market, but it's also producing reactors. And this is a kind of a key point, because once you've filled up your reactor farm, and your facility is producing power and heat and hydrogen, because of course the gigafactory could also have the option to be connected to the grid and support future electricity grid with high penetrations of wind and solar to supply electricity during a seasonal lull. But actually, once your reactor farm is filled up, you can then also start sending those, keep making the reactors and send them out to repower coal plants, or to be co-located with industrial facilities to supply heat directly to support the decarbonization of industry as well.
Brilliant, thanks very much. And if I could pass the mic to Edward, for Dow, is there something specific that Dow is doing, a partnership that it has? What is it that Dow can offer to this, finding this solution to decarbonizing sectors other than electricity?
So I think, just maybe as by way of introduction, Dow Chemical makes plastics, silicones, lots of things like toothpaste precursors, pharmaceutical precursors, things that are essential to decarbonizing the economy, to providing lightweight transportation of things, keeping food and water packaged properly and cleanly. And so it's important, those are fairly energy intensive processes for the production of those molecules and chemistries. And we've set a goal to decarbonize by 2050 and to reduce 5 million tons a year of our emissions by 2030. And that rate is actually faster, about 50% faster than the rate of decarbonization we've achieved over 2005 to 2020. So we've been at this decarbonization for a while and deploying efficiency. And we put together, basically, once you know where you're going, you can start where you are and decide how do you want to get there. And we looked at every one of our more than 100 furnaces and more than 50 gas turbines and steam turbines and boilers. And we plotted out when we would replace what. Because what you don't want to do is take a brand new boiler that you put in 2 years ago and shut it down if you have another one that's 40 years old that you could do instead. So you have to get the sequencing right. And that then said we needed a path. We have a path that we put together with a hypothesis of how this was going to happen, which asset at what time. And it's not perfect. We'll change things over time, but at least we have a path to walk down. It became clear to us that we had, maybe 2 or 3 different types of sites. We had sites that were very power intensive, and for those, frankly, renewables look pretty good, particularly if you can get them as part of a kind of combined with a hydro type solution. Renewable works very well for that. You can also get sites where, they're smaller, and that becomes difficult because what you'd like to do there is buy renewables, maybe with some hydrogen, because you probably also need some heat. And that heat is we need to burn things to create the heat that we need. So a lot of our processes require 500 to 800 degrees C. It's not that you can't really today heat those with electrification. There's just not enough heat flux in the current ceramic systems that allow you to do that. So in those cases, we can be off-takers of hydrogen from a local grid or a source. And we're very big believers that the cleanest and cheapest and most effective way to create clean hydrogen is one of 2 forms. Either from nuclear, which is, as you said, a product stream off a reactor that's quite attractive, or you can use blue hydrogen, where you decarbonize a methane stream and create hydrogen and then CO2, which you sequester. The final type of facility we have is one where we actually have a lot of power and a lot of steam. And for that, there's a couple of different things we need. One is that we need redundancy, because typically these are very large manufacturing sites. So think power grids that look like a small US state. You know, these are millions, you know, they're gigawatt scale power grids. And so, you know, I'll say, we've said publicly that at Dow we use about 7 gigawatts of power and steam. And, you know, that's not 7 gigawatts of capacity, that's 7 gigawatts of consumption. So, you know, what is that, 63 terawatt hours per year or something like that? Anyway, it's a big number. 7 world-scale nuclear plants today. In those cases, what we'd like to do, and what we have today is a cogeneration facility where we have maybe 4 gas turbines that are redundant with each other, so we can take one off and have another one fail and still provide our reliability. What's attractive to us about small modular reactors is that they provide an appropriate scale for our facilities where we can match the thermal demand and the electric demand in a way that allows the facility to continue selling power to the grid on the increment. We use basically all the steam from 2 of them, and then we have some redundancy that can also go through a steam turbine. And what that allows you to do is have a very, very efficient use of nuclear energy with redundancy for us, with power and steam, and that makes it quite economic. And by our calculations, that's pretty, you know, that will be attractive versus a gas turbine with carbon capture on it. It's probably a comparable sort of cost position. So then the question becomes, okay, this sounds great. How do I get there? How do I do this? And so about 6 months ago, well, about a year ago, my CEO declared at CERAWeek that we were going to do nuclear. And you know, he did this without telling the rest of us, by the way. And you know, he said we were going to deploy nuclear at some of our Gulf Coast and our facilities in North America. About 6 months ago, we announced a partnership with a company called X Energy, where they have a small modular reactor. It's a gas-cooled reactor. It's HALEU technology, and it's inherently safe. About 200 megawatts thermal scale, about 80 megawatts electric scale, which fits very nicely with the scale of our facilities. So we're developing, and we declared that we would deploy one of those at one of our US Gulf facilities by about 2030. So now we have a date, and we have a technology. We're doing, you know, we're looking at site selection, and we will then need to develop the economics of how this works and the operator model, because X Energy is a technology company, we're an off-taker, and we may need some partners as well to make this happen. But it's amazing when you have a date and you have a technology and you have an attractive value proposition, how quickly you can start getting action and moving forward. So I don't know if that's a good introduction, but that's
a great introduction. Thanks very much, and really appreciate it. And it's a great example of a company really looking at the problem, looking at the solutions, and for some applications, seeing that nuclear is actually the best way of going forward, and therefore going ahead and doing it, even if it's announced by one person and it's slightly a shock. But that's a good way of doing things. So that's an example of a company coming to that conclusion. I wonder if I could ask you to pass the microphone to Alice. Alice, can you tell us about specific applications, or what is the potential for industrial heat from nuclear and hydrogen for South America?
There is a lot of potential. For example, in Brazil, the nuclear power plant has actually been producing hydrogen for the past 20 years already. And they have been releasing that, not using. It is not to electrolysis, it is to a chemical process due to the salt water, but it's still a powerful resource that Brazil has, and they had not been leveraged. And for 20 years of this hydrogen production, they were not using it. So finally, there is projects ongoing in Brazil to leverage this hydrogen produced in the nuclear power plant to be used by the country. So there is a lot of potential on South America for the use of hydrogen, and this is just one simple example of that. Another one, when we talk about transportation, it's funny, and sharing a personal experience, there is this paradisiac island in Brazil called Fernando de Noronha, and they for several years are talking now about how they need to have a very clean transportation system in there, so electric vehicles. But this island is 3 days by boat to get there, and they have a diesel generator plant in the island. So if you electrify the vehicles of the island, but you still use the diesel generator on the island, you are not actually doing what you're supposed to do to make that paradisiac location, which I recommend everyone to go if you've never heard. Fernando de Noronha is the name. So there is potential on this as well in cases of like faraway locations. They need electrified transportation, how you can actually make it clean. And something that I don't know if people consider or not as decarbonization, but when we talk about nuclear technology, beyond the power reactor, we have been talking here at COP about the potential of nuclear technology with agriculture, for example. So we had the opportunity to hear the Food and Agriculture Organization, the Director General, talking about how nuclear technology can aid with efficiency, with more sustainable agriculture. And agriculture is extremely important for South America, for Brazil particularly. And if we use these techniques, if we reduce waste, or when we export, for example, with food irradiation and things like that, it can help also on that because you are being more efficient. So you are decreasing the emissions that you would be producing through the agriculture. So it's not necessarily nuclear reactors only, but another way on how nuclear technology can help another sector reduce the emissions. And that's a reality for my country.
Thanks very much. If I grab the microphone for you, and I'm going to pass it back to Kirsty, because Kirsty, we heard Edward describe about how Dow had looked at what it does and looked at ways in which it could decarbonize, and it saw a range of options. Sometimes it's nuclear, sometimes it wasn't. And of course, with electricity, we know we need to use all the options, but there are advantages to some options over others for specific applications. So does it apply to production of hydrogen? Is there any particular advantages of nuclear technologies for producing hydrogen?
There sure are, yeah. I can just list 4 for you. So first of all, you can potentially produce very low cost power and heat, subject to a highly automated, high productivity manufacturing based model, which the SMRs are very well suited for because of their size and because of the way that they're being designed. So that's great. Secondly, you have a high capacity factor, which you mentioned for industrial processes is absolutely key. If you're supplying power or heat for the data center sector, or indeed for many of the industrial applications, you really need real reliability. That means you have to have 99.999% of the time you can, so this technology is very well suited to that as well. The next thing is that you have a very small environmental footprint. So, we have a very power dense opportunity here, which means that actually siting is much easier for some of these potential customers, whether you're an industrial user, or if you're decarbonizing upstream oil and gas production, for example, or if you're looking to repower existing thermal generation plants. They're not necessarily going to have 30,000 acres of land available to them to build a solar plant, which would be equivalent to a 500 megawatt, power plant, right? So the density is really important because it means that you can match the footprint of the existing facility that you're decarbonizing. So low cost power and heat, high capacity factor, very dense, small energy footprint, all of which contributes. Oh, and then one other thing, of course, I just want to double click on the heat, because actually when a lot of the industrial users and energy consumers that we're talking to talk about the options that they're considering, they might be considering carbon capture and storage, but that comes with its own set of challenges regarding sequestration as well as cost. And then hydrogen itself as a sort of end-use product, you could convert a coal plant to run on hydrogen, for example, but where's the hydrogen going to come from? And how do you store and distribute and transport hydrogen? It starts to get very, very expensive. So really achieving scale is the key. So many attributes from nuclear technologies that can make hydrogen very cost efficient, because the application of heat enables high temperature electrolysis or even pyrolysis or thermolysis, all of which represents higher efficiencies, lower cost, larger volumes of production. So all good things. Definitely something to consider, and hats off to Dow for seeing that opportunity.
Thanks, Kirsty. Yes, I would like to pursue that line if I can a bit more, because Dow, not a nuclear company, forming a partnership with X-Energy. So there's two questions I'd like to ask, if we can combine them. One is, what is the importance of partnerships when we look at this issue from your point of view? And Dow, as a non-nuclear company, what are your reflections on how nuclear works with innovation?
So, all right, so I think it's important to have like an ecosystem of organizations that are trying to do things that are mutually aligned. We aren't developers of nuclear technology. We are very good at using process heat, and we are very good at efficiency and scale. And we have to be, because the stuff we do is at 2.5 million tons a year type scale for a single unit. So that's what we can bring. We also have a good balance sheet and a long-term offtake that's going to be stable, and the facilities that you hook up to are going to be there for a very long time. We need partners who are good at getting things permitted and understanding the technology and doing that. We also need partners who are good at figuring out ways to creatively finance this. I'm not convinced that Dow is the best owner of these technologies necessarily. There may be others who are better owners of the plant itself. And we may not be the best operator of this technology specifically, because it has the high reliability that we need, and it has the high kind of resilience to issue, to any sort of issue that might happen. So I think that sort of technology ecosystem needs to work together. And then you also need to interact with the governments, because what happens is one partner is probably more attractive an advocate for, say, the nuclear permitting teams. Others may be more with state government. Others may be more with the local community or the workforce or the federal government. And these are things that in some cases we Dow can bring, in other places a technology partner or even an owner-operator would bring. So without that sort of collaboration, I don't think you're going to get this done. And I think by doing it together, each of us gets something that isn't available to any of us alone.
Very good, thanks. And I wonder, Alice, please, I'll be interested in your views on innovation.
Yeah, if I may add to that, I completely agree. Without collaboration, we are not gonna get there. It's not a doubt. It's important for us to have this in our mind, that this is a global issue that involves many different industries, that involves governments, and that involves different scenarios for different governments, for different countries. So it's something that we have been discussing here, like at COP, for example. The negotiations are going on, exactly talking about how can the Global North collaborate with the Global South, how can we deal with some countries that can decrease demand, some countries need to increase demand. So within the energy industry, its collaboration is essential. And that collaboration also helps with the innovation aspect of it. Because if we are on our own boxes, trying to solve certain things within ourselves, other ideas, other opportunities may not come to it. So collaboration is actually essential for innovation, and without innovation as well, we will be very hard for us to get there as well. So I don't think like partnerships, as I said, governmental involvement, industry involvement is non-negotiable for us to solve the crisis that we have. And I expect and I hope that this is going to increase much more than what it is being done now, and that we find more opportunities to partner with different industries, like you mentioned, for us to find solutions for the problem that we face.
Thanks very much, Alice. Now, we have a lot of people in the room here, so I want to give an opportunity to you to ask questions if I pause mine. So if anybody would like to ask a question about any of the issues raised so far or anything else relating to decarbonisation, just please show your hand. I have one immediately down the front here. I think you'll have to use my mic.
Thank you. My name is Jesse Solomon. I'm a state senator from Washington State in the United States. And my question is, what can we do at a state level, policy-wise, to help bring about more nuclear energy as a clean, renewable source of energy in our portfolio?
Yeah, so I think you have Hanford and a lot of experience with nuclear in Washington State. And as far as I remember, X-Energy is also trying to move forward with a first facility there. So I think, the important thing is to position this appropriately with the local communities, and to make sure that the input from the community and the input from the state level governments towards the permitting process is a positive, and moves forward with appropriate concern, but with appropriate speed, because the historical problems with nuclear energy were that they took too long to permit because they were bespoke solutions for each one. They cost too much because they were bespoke and because they took too long to build. And those two problems can be addressed by a more sort of collaborative and appropriate relationship with the permitting process in the local communities. I think the other thing to do is it's important to differentiate the designs that we're talking about today in terms of an SMR with a 2025 type design is very different than a conventional nuclear reactor that was built based on a 1970 design. It's inherently significantly safer and has a very different sort of footprint in terms of scale and community exposure, that sort of thing. So those would be the two things I would say. So it's education and sort of appropriate collaboration.
Thanks, Edward. And Kirsty, would you like to add to that?
Just very briefly, I would say that there's an opportunity to really focus in on the kind of equitable transition as well, with the application of these technologies to enable the continuation of carbon-intensive industries across the US. We're seeing, states throughout the US overturning historical moratoria on nuclear energy because coal plant communities are facing an uncertain future and seeing an opportunity to maintain the socioeconomic benefits and the jobs associated with the continuation of those plants by replacing the coal burning with small modular reactors. Now those heat sources, as we've been talking about in this session, can also be applied to other industrial practices and could help also to sustain the ongoing socioeconomic benefits of industry in your state as well.
Thanks, Kirsty. Do we have any further questions from the audience? We have one over on the right side. Thank you.
Hi, good afternoon. I'm Gary Rose from Ontario Power Generation, likely X-Energy's third deployment. But my question is really about decentralization of nuclear. So to date, most nuclear plants are in large central locations where you manage an exclusion zone, etc., for SMRs and these types of SMRs that we're talking that need to be co-located, co-generation opportunities with industry, it takes a different approach to deployment of these reactors. And I wonder if there's any opinions from the panel on what things can be done differently to address this decentralization of nuclear, which is quite new in my opinion.
I can talk about Brazil, for example. There has been an effort in the government to look on technologies for decentralized. Brazil, like US, is a continental country, and although we have a very large power line and grid, there are locations that, for example, it doesn't reach yet. There is loss of efficiency and so on. There is faraway communities. There is need for like industrial heat and things like that. So in Brazil and in different countries around Latin America and so on, there needs to be like a governmental decision on regarding a federal government decision regarding the decentralization. But it is something that it is already being looked at exactly for the need, or not only decarbonizing other sectors, but for the need for energy, like electricity per se. Because of the structure of the country and how the grid was developed and it is now. So in my perspective, it is essential to look for from both sides, a centralized and decentralized energy production. Yeah.
So I'll say three things. So the first thing is that, you know, at Dow, whenever we deploy a technology or a process at our sites, we go through our usual safety protocols. We make sure that there's no impact to our communities and our facilities per our usual approach. And we've got years and years of experience of doing this and doing this in a smart way. We believe that these technologies are appropriate for our facilities and will be appropriate when used in those sorts of facilities. If at some point we didn't believe that, we wouldn't deploy. But for now, everything looks good. The second thing to say is these new technologies are smaller scale, and so their safety zones are materially different in scale and size. What that means is you can deploy them in an area that is, let's say, less remote from a population center. And that can be, particularly with the advent of renewables that are quite a long way away, you know, you end up building an awful lot of transmission cable if you're not careful. And having a smaller scale nuclear facility deployed closer to a population center can have real significant positive effects for the stability of the grid, particularly in a very high nuclear thing. And so, you know, that's the second thing. I'm trying to think what the third thing was. Yeah, so maybe I'll leave it at that for now because I can't remember what the other one was. But
we'll come back if it comes back. Kirsty, I do actually want to ask a nagging question that's been on my mind, which is related to the question, which is this. You talked about the UK would need 10 gigafactories to replace sin fuels. That, to me, sounds a lot like the same path as large-scale reactors. So large plants, not so many of them. So related to that question, with hydrogen, if you want to use the hydrogen, you don't want to transport it far. So does the idea of the gigafactory scale down? Can you have mega factories or just factories? Could we use the same approach to have more but smaller so that the production of hydrogen was closer to its needed use?
Yeah, thanks. So the example of the 10 gigafactories, they're producing hydrogen, enough hydrogen to produce synthetic fuels to replace the oil and gas. And the synthetic fuels like ammonia, synthetic hydrocarbons, you can move around much more easily than you can hydrogen. For the industrial users, you know, for the steel industry or, you know, oil and gas sectors, for example, they have astonishingly large needs for hydrogen. So there might be that they need like 10 gigawatts of, you know, hydrogen production co-located with their facility. It's very big. So that's even the gigafactory scale. And then that would make sense to co-locate if you're using the hydrogen as an end-use fuel with your facility. And there are a lot of off-takers, and that will be quite a large market. However, if you do want to produce fuels that you can actually distribute around the place, I don't think hydrogen is a great fit, because our analysis suggests that if you need to move the hydrogen any distance, you're going to radically increase the cost. I mean, you could double the cost of the production just to sort of transport it to the end user. And it's difficult to store and transport. And, frankly, our high theory of change is we need impossible burgers for climate. Okay, so if you haven't heard this from me before, sorry, but there's an analogy we like to use. Impossible burgers are plant-based meat substitutes that look like burgers, taste like burgers, cost the same as a burger, and you can buy them in any Burger King, and they don't require any behavior change. We need impossible burgers for climate, like drop-in substitute fuels, or the application of emissions-free high-temperature heat that just is exactly the same in terms of the cost and performance of the fossil fuels that we use today. So that's what we're trying to design for. Yeah.
Thanks very much. So I had a bonus question. Any other questions from the audience, please? If you just raise your hand. One at the front here. Thank you.
Hi. So what proportion would you say of existing industrial sites are ready to accept SMRs, and what proportion would you need to rebuild those sites in some way to accommodate for an SMR?
I think I would answer it. I would ask the question differently, because I think this concept of a path is the most important thing. We can't afford, from a carbon perspective, to leave something with useful life unused. You will use so much carbon replacing it that you'd be better off just using it a little bit longer, because we're not going to have enough capital to deploy to take care of everything anytime soon. So the point is, what you want to do is deploy your capital as efficiently as you possibly can, which means that you lose as little remaining life as you possibly can. So our plan is to replace our gas turbines when they get to roughly 40 years old. And since we've got gas turbines that are anywhere between 10 and 40 years, that means 30 years is a very fine time to do this, and that's 2050. What I would then say is, in our large, maybe to give you a sense of scale, because I don't know the answer to the question you're asking, but I can give you an example in our large petrochemical facilities. So we produce a compound called ethylene from an ethane or a naphtha feedstock, and we turn that, we basically heat that to about 800 degrees Celsius, and it loses a hydrogen and becomes ethylene. Or if it's a naphtha, it breaks down into, from 20 carbon or whatever molecules, 16 carbon molecules to 2 carbon molecules, and becomes ethylene. Those facilities have about a third of their energy is for fired heat in the furnace, and about 2/3 of the energy is for compressors and separation and heating stuff up and cooling it down and all that sort of stuff. So an SMR is a really great solution for the 2/3, and for the 1/3, it's actually a different sort of SMR you need. You need a steam methane reformer, where you take the methane that's an off gas of the machine, and you take the C out of it and turn it into CO2 that you then sequester. And then you put the rest of the hydrogen from the CH4 or whatever in methane, and the hydrogen that came off the C2H4 that's becoming C2H2, and you turn that hydrogen into the fuel for the furnace. So we call that circular hydrogen, and some would call that sort of blue hydrogen, but it's not really the same thing, because the fossil fuel we're using is kind of going into, it's going to become a plastic. It's not going to be burned. So you put those two together, but I think the point I would make is, the next thing I would say is, you need scale to deploy something like an SMR. So I would say for us, we have probably 15 or so sites around the world, maybe a bit more, where we could deploy SMR scale type machines. And for us, that would be 90% or so of our emissions. So, it's pretty important. It's not dozens and dozens and dozens of sites. If you've got a small compounding facility somewhere, what you need is renewable power, maybe with a little bit of hydrogen to burn, to heat a boiler up for some steam. But the majority of our emissions actually come from very large sites. So smelters and crackers and ethylene oxide, propylene oxide. These are giant facilities, So I hope that helps.
And if I may add, in the path that we have to take, we always need to take into account licensing and public opinion as well. So, for example, we may, in certain countries, the licensing process may have like different applications. For example, in the US, private companies can operate nuclear reactors. That is not a reality in some other countries. That needs to be operated by the government. So how you combine the need for industries to leverage the nuclear technology for process heat while dealing with the restrictions and limitations of a governmental law that only the government can operate this type of technology. So there is the licensing and then the limitations of the way the nuclear sector is structured in certain countries, for example. And of course, public opinion has very important aspect to it, in industries feeling like understanding the importance and the advantages of leveraging nuclear technology and leveraging it for the services, for the production and so on. So that I would add actually three factors: licensing, government, nuclear sector in structure, and public opinion as well as part of the path for going forward with.
Thanks very much, Alice. Looking at the time, I think if there is one for just one more question. But if not, what I'd like to do now is, there is a question.
Thank you. So my name is Sama Bilbao. I am from World Nuclear Association. So this is, you mentioned, several of you talk about innovation, and you very much focus on technological innovation. So is there an opportunity, or more importantly, a need for other types of innovation? So innovation in the business models that we are using, innovation in the policies that governments are launching, innovation in the market designs that we are using to price and distribute energy or electricity. I don't know whether any of you have some thoughts on this.
Perhaps I could turn to Kirsty first.
Yeah, thanks, Sama. That's a great question. And actually, I think, it picks up on the question we just heard, which is, how many of these industrial users are ready to cite an SMR, for example? And so we will need to innovate in terms of the business models to make the energy available to these industrial users, because in our experience, we're working with many of the oil majors interested in the application of nuclear heat for their upstream decarbonization as well as the production of clean synthetic fuels. They really don't want to be owners and operators of nuclear plants. But sort of as a sort of more macro point I would make, this is a critical decade, as we are seeing the demonstration and commercialization of a really wide range of light water SMRs and advanced high temperature heat sources. And as these technologies are coming to market, we have a big job to do to work on all those things, Sama, that you mentioned, to ensure that the financing mechanisms are in place, to ensure that the siting and licensing and community engagement and supply chain and operating capabilities are ready. Because when these technologies come to market, we don't want to just build one, we want to start seeing hundreds and thousands of these technologies being deployed to decarbonize these very tough to decarbonize sectors. So, we shouldn't be complacent. I don't think we are being complacent, but just because these technologies won't necessarily be ready and commercially available until 2027, 28, 29, we have a lot of work to do to ensure that when they are available, that we can deploy at the speed and scale that's relevant to the scale and time scales of our climate challenge.
Thanks very much, Kirsty. And Edward, your views on the question and any other concluding thoughts?
Yeah, so I would say absolutely new business models are required. The traditional nuclear plant was 1 or 2 gigawatts, was built by a utility with a rate base on a 30-year time frame where the local community agreed to pay for it. An SMR is going to be more aligned to a market without an underlying rate base. It's probably going to have a steam offtake kind of power, a steam producer agreement with somebody. It may have a hydrogen offtake agreement. There may even be other sorts of agreements for isotopes. There's also more than likely in a post-renewables power market world, very important ancillary service type revenue streams, because these things do run 24/7, 365, and renewables do not. And so putting all those together and then finding a appropriate financing mechanism is where real significant innovation is required, because a traditional nuclear plant is in effect financed by the state, by the guarantee of the state that the utility is going to continue to be able to sell power to it. That doesn't exist for these sorts of facilities, so you're going to have to cobble together coalitions of companies that have, excellent credit quality, like say Dow does, and then put that together with other sources of revenue that see upside, that incentivize investment from credit facilities like banks or other funds. So I'd say it's a big problem, but it's also a huge opportunity. And I'm a believer that a more structured, flexible, and kind of return-based approach is going to be a much cheaper way to deploy nuclear than a kind of conventional rate-based. Take 20 years and the cost goes up and my rate returns go up and everybody's happy except the consumer, right? So no local utility board is going to approve a nuclear plant because they all have that experience, which means that the only people who are going to do it are going to have confidence and comfort that it's not going to be that. And so that's where the innovation is required. I mean, I guess as a concluding thought, we are going to a carbon neutral world. You can't do it without nuclear. Innovation is required, but we're starting to walk down the journey, and we're happy to be leading in that. And I think that's where we are, and we have to lead, because if we lead, no one will catch us. And that's the plan.
Thank you, Edward. And then we can give the last word, please, to Alice.
Yeah, I would say we need a mindset shift. We are bringing revolutionary technology, and the way we do business now doesn't fit. So we need to, as Christy and Edward very well put, we need to change and innovate in several different aspects in order for us to be able to implement properly and leverage all the capabilities of what we are bringing in a way that is more efficient, is better used. So if we continue with the same business models, with the same mindset, with the same way we do things, we are not actually leveraging everything, all the power that we are bringing with this revolutionary technology. So I think both the market, both the nuclear industry and energy industry all need a mindset shift and work together to find these different innovative solutions for all these points that are needed, including the licensing process, for example. Yeah. So as a conclusion, I think, as I said before, innovation, partnerships, and collaboration between the most very different sectors are non-negotiable, and I want to emphasize that we are moving to a net zero world. We still have countries in the global south that need this net zero world to happen, allowing them to get where they need for their people to have their basic needs fulfilled, to have abundant life. We heard in the opening ceremony here a representative of an African country, I cannot remember from where, that told that has around 100 million people in Africa in energy poverty. So we need to, in the globe, much more than that. So we need to deploy all the different technology that we have, decarbonize the most various sectors that are carbon intensive in parallel for us to get to where we need to be. And without working together, without innovation, that's not possible.
Thank you very much, Alice. Well, with that, I'd like to conclude today's event. I hope you've enjoyed it. Thank you to all those who are here in the room for your attention and your questions. Thanks to those who are watching online as well. I hope it's been very useful to you. And I guess to get back to your analogy, Alice, of we're operating on open heart, that's because the world's sick. And I think we need some nuclear medicine. So thank you, Alice, Edward and Kirsty. Thank you very much. Will you please join me?